Right, I'm doing a bit of a marathon here. Let's do all three back to back. One would argue that part three should be the hardest. One might also argue part three should be the funnest. Let's find out. Alright, a random variable probability density, well, probability density function. There it is. Okay, that looks like a straight line to me. Find this, this, and this. Cool. New page. What question was this? 25. We're using I's or A's? A. So I want the probability that's between 3.6 and 5.6. Doesn't matter if that's equal to or not. Okay, so basically I've got that as a function. It's a straight line, cut with the origin between 3 and 7, wasn't it? Yeah. So that area is going to be 1. So between 3.6 and 5.6, the area should be less than that. So I'm looking for something less than 1. Okay, so this is the integral of between 3.6 and 5.6. So remember, I'm just using my graph. I'm just looking for the area of this curve. That curve being 1 on 20 x dx. That could really just come out front. 1 on 20, 3.6, 5.6. So that's just x dx. That 1 on 20 stays out there. Raise it, divide by it. That's a half x squared. 5.6, 3.6, 1 on 20, outside of a half, 5.6 squared, minus a half, 3.6 squared. I chuck all of that into the calculator, and I get 0.46, which is less than 1, which was what I expected. Cool. Now, EX, okay, expected value of x. Now I know that that's the sum of x, probability of x. In terms of a continuous function, it's going to be now the sum of x, and then the probability of x. Well, that's just my function, which is 1 on 20 x dx. It's defined between 3 and 7. And I've set up my rule. Now let's solve it. So I'm going to bring this 1 on 20 out again. That's 37. That's going to be x squared. 1 on 20 outside of raise it, divide by 1 on 3 x cubed. 7, 3. Let's bring this 1 on 60 out. Now I've just got 7 cubed minus 3 cubed. Okay. And that off the top of my head is 79 on 15. That doesn't have much meaning, so the decimal equivalent might make more sense. 5.27. I'm making sure that that's in between here and here, which it is. So cool. So this is basically like, here's my function, here's 3 and 7. The expected value is around about 5.2. So there. All right, and C. Let me find another page. C. My variance. These formulas on your reference sheet. The variance is the expected value of x squared minus the expected value of x all squared, and we know what that is. Okay, so the expected value of x squared. So I'm going to do the exact same thing as I did up here, except with my function squared, my x squared. So between 3 and 7, I've got 1 on 20 x, and then I'm timesing that by x squared. I'm good so far, dx. And I take away this, which is this, squared. I'm taking away 5.27 squared. Brackets around that. Okay, so this time I've got 1 on 20, 3, 7, x cubed. I feel like I'm doing the same thing over and over again, just changing my... Maybe I need this to be exact. 79 on 15 squared will make more sense. 1 on 20. Raise it, divide by 1 on 4, x 4, 3, 7, minus that chunk, let's leave that. Let's bring in a 1 on 8, that's going to be 7 to the power 4 minus 3 to the power 4, minus 79 on 15 squared. I type all that into the calculator, and I get 284 on 225, which is around about equal to 1.2. 26. So I've got an expected value of this, and an variance of that. That kind of makes sense to me. Okay, 26. Of all first year students, okay, this is going to be hella confusing. Let me get a new page. 26. Okay. Of all the first year students at one of Sydney's major institutes, 80% are local, and of 10% hold a scholarship. Okay, let me skip all that. If a randomly chosen student holds a scholarship, what's the probability that they're non-local? Okay, that's a given. So what's the probability that given that they hold a scholarship, a randomly chosen student holds a scholarship, what is the probability that they're non-local? Okay, so let me just wrap my head around that. B, call that probability. Okay, so the probability of something given something. Okay, the thing that's given, so that's this one's given. Let me just write that. The one that's given is that they hold a scholarship. So they hold a scholarship. What's the probability that they're non-local? So non-local, so local non on top. Okay. Now this is also on your reference sheet. It's probability of that union that on probability of the second one. Okay. So the probability of the union of non-local and scholarship. Okay. So it's like the overlap. So looking at the question, 80. Looking for people that are non-local and have a scholarship. So non-local. Okay, see the second sentence. Of the non-local first-year students, 75% are scholarship holders. So it's 75%, 0.75%, but it's of the non-local students. So it's 75% of an amount of students. So now the non-local students, it says 80% are local, so that means non-local is 0.2. So it's 75% of the local students. That's the percentage of people that are, this is so confusing, that are non-local and have a scholarship. Well, I'm feeling the second half's going to be worse. What's the probability that, now I need this, the probability that they have a scholarship? Well, there's actually two cases. I'm going to need the thing. There's two cases. So the probability that they hold a scholarship is 80% times 10%. So see how I've got local people, 10% of those hold a scholarship. So it's 0.8 times 0.1. 0.8 times 0.1. But there's also another scenario, and it's the people that, so that was the local people. Out of the non-local people, there's 75% of them. So that's 0.2. 0.2 times 0.75. That's, yeah, this is a hard question. I'd say you can surely get a mark for each of these, I reckon. I type all that into the calculator and I get 15 on 23. Okay, so that's, maybe I should label some, what did I just say? This was, that's local. That's non-local. These are, they hold scholarship and are non-local. So the and is this. Union. Okay, I don't feel like I can explain that any better. Well, I couldn't, I bet someone else could. Alright, suppose that A and B are independent events. Given that PA, let me write that, probability of, what's A? Oh, okay, I'm not told anything about anything here. Probability of A is equal to 2 times the probability of B, and that the probability of their union is equal to 0.52. The probability of A is something that I don't know. Okay. Well, I'm just going to start with this. Probability of A union B. I'm pretty sure this is on your reference sheet. I certainly hope so. It's the probability of A plus the probability of B minus the probability of the intersection. And you can think of it like this. If I've got A and B, probability of their union is everything, right? So it's all of this plus all of this, but I've counted this middle part twice, so that's why I take it away. So that's the union formula. Now I know that I'm going to make a substitution here. I know that PA is just 2PB. So I'm just going to replace this with this. So 2PB plus P, why is my pen doing this? Minus P, A, B. Okay, so then that's 3PB. I actually know what this is, it's this. So 0.52 minus the probability of the intersection. Okay. Okay, I feel like I'm going to need to do something with this. What else does the question tell me? Oh, okay. Okay. Remember before when I said okay, so when I drew this, the question tells me, so if you look at the top, the question tells me they're independent, which means there actually isn't an intersection. Now, one thing that that is a thing with independent events is that when they're independent, this is equal to the probability of A times the probability of B. So when they're independent, if I just go, what's the probability of this times probability of that, it's going to give me the intersection, which is nothing. So that's true. Now I know I'm also going to make the substitution for this. So it's basically saying 2PB times PB again. Yeah. Okay. Okay, equals 3PB minus, oh, okay, this is 2PB times PB, so 2PB squared, 0.52. Okay, so this is actually really strange, but it's turned into a quadratic. So I've got a squared term and a normal term, so I'm going to move them to one side. This is really weird. So 2PB squared minus 3PB plus 0.52 equals 0. Now I can use the quadratic formula. PB is equal to, you could make a substitution, like you just call this thing x, so then that's x squared and that's x. You could do that, but who cares? Minus b, plus or minus the square root of b squared minus 4 times a times c, all on 2a. Okay, when you do that, you end up with 1 on 5 and 13 on 10. Okay, now it can't be this because that's greater than 1. So I disregard that. So it's just equal to 1 on 5 because I'm looking at probability. A probability can't be bigger than 1, so that one makes no sense. You're always going to find one makes no sense. And it's kind of weird because normally you'd say the negative one makes sense, but because we're talking about probability, it might, like, is this 3 marks? This has to be. Yeah, okay. What did the question even ask? They're asking for PA. Oh, okay. Well, that's the probability of B. We know the probability of A is equal to 2 times the probability of B. That was given at the very start. That's 2 times 1 on 5, which is equal to 2 on 5. So the probability of A is 2 on 5. Wow, that's a long question. Look, these are fun ones. Okay, 28. Water is being pumped from a new page. To that monster question. So 28. Okay, A. Water is being pumped from a reservoir. The volume is decreasing at that rate. Okay, so the rate of change of the volume with respect to time is that thing, but it says it's decreasing. That's a key thing. So minus whatever that is, 360. Being pretty kind by giving me some brackets here. I'm just going to rewrite that as 30t minus 360. So just swapped everything. Find t, the number of hours for which the pump is operating. Number of hours for which it's operating. Okay, so I guess once it stops, so when it stops, then the rate of decrease will be 0 because there'll be nothing left in it. So I'm looking for the rate when it stops. So that tells me that it's stopped coming out of the pump. So that's 30t minus 360 equals 0. That means 30t equals 360. That means t equals, how many 3's go into 36? 12. So 12, what are the units? Hours, number of hours. Okay, so 12 hours. B. Okay, given that the volume of water remaining in the reservoir after the pump stops is 240 ml, derive a formula for the volume after. Okay, so I know what dV dt is. That means if I were to integrate that, so V equals the integral of dV dt. I hope that makes sense. So I'm just integrating the rate of the volume to get the volume. Alright, now I don't know what any bounds are. I do know what this equation is. It's 30t minus 360 with respect to t, because there's obviously t's in it. Okay, that's equal to raise it divided by, so it's 30 divided by 2, that's 15t squared minus 360t plus t. They told me some initial conditions. It's that the volume is 2400. So volume is 2400 at time after the pump stops. So that's at time 12. And last question. This is kind of meaning like the first one you screwed, or whatever. Okay, so that means subbing it into here, 2400 equals 1512 squared minus. The whole point of this is to find out what C is. C. Okay, rearranging C equals. So I'm going to move all that over there and chuck it in the calculator. What I get is 4560. So therefore, my formula is 15t squared minus 360t plus 456. Oh, okay. That's easy. I don't know whether that's worth 3 marks, but I'll take it. Question 29. Spyro, property developer, it's only 5 mil. Okay, it's I show that question, so it's giving me what I'm aiming for. So that's pretty generous. Let me make a new page. Question 29. Is it A? Yeah. Alright. Write down an expression for A1, A2, and hence show that A3 is equal to that. So this is one of those ones that I'll always tell you about, that they're always exactly the same. Once you get it once, you're good. Alright, 5. Okay, just one clue. See how they've written 5 times 10 to the power of 6? That's just another way of writing 5 million. So I'm just going to use their notation so that I know what I'm aiming for. That just stops me from using gazillion zeros, I guess. But other than that, there's no real reason why they've done that. But since that's what we're aiming for, times 10 to the power of 6. That's what he puts in. Let me start with A1. Oh my god. A1. Okay, so he starts with that. Then what happens to it? It has an interest rate of 3.6% per annum, and he's making annual repayments. So I don't have to change anything. There's no monthly stuff here. That's kind of cool. Right, so so 3.6, so it's increased by that. So it increases, so 1 plus 0.0366%. Okay, and that goes once, compounds after the year, then he makes a repayment. So I take away Y minus a repayment. He's not making a contribution, he's making a repayment. So I'm taking that away. Yeah, that makes sense because he's putting towards it. Okay. At the end of each year, so he does this for 10 years in a row. Oh, I only care about A3. Okay, that's A1. Can I take that up? Not really. I can go 5 times 10 to 6, 1.036 minus Y. Now A2 is going to be A1 compounded, and then the repayments made. A1, I'm going to put all of this into here. So 5 times 10 to the 6, 1.036 minus Y. These questions are identical. Every single time, it's exactly the same. Now, all of this times this is just going to put a 2 there. And then that times that would be Y times that. So 5 times 10 to the 6, 1.036 with a 2 minus Y times that minus Y. So I can factorize this Y out. So Y outside of 1.036 plus 1, just be careful. Okay. A3 is A2 compounded. I'm doing that, and then I make a repayment. A2 is all of this, so that's all going to go in here. 5 times 10, 6, 1.036, 2 minus Y. How's everyone's day? 1.036 minus Y. Okay. Now, all of this, so I'm distributing this. So when I times that by that, that's going to put a 3 here, and then it's going to put 2 here. I'm earning my marks here just by the sheer amount of writing I've got to do. No, that's not going to put a 2 here. It's going to put, here it is. It's going to put it, let's just write it out. Oh my god, my hand's getting sore. Alright, now that and that's going to put a 2 there, and that's going to give me this there. Did my thing just go yellow, or am I losing my mind? Okay, minus Y, and I'll factorize the Y out, and hopefully I end up with what I wanted. I haven't looked up at my answers in a long time, so I think this is correct. It is, they've just written it backwards. Okay, I'm pretty happy with that. And they put multiplication symbol next to the 10 to the power 6. Okay, that's 2 marks. That'll work out 2 marks. It's pretty easy though. Like I said, it's exactly the same. Okay, find the annual repayment, correct to the nearest dollar. Okay. It tends to make an annual repayment of that at the end of each. So I'm trying to find, the whole point is to find the annual repayment, which is Y. y is what I'm trying to find. Now I don't actually know what A3 is, so like I was thinking I could go like this and just like rearrange it for y, but I don't actually know what that is. What do I know? What do I know? What do I know? What do I know? He's borrowing 5 million and makes an annual payment for 10 years. Okay, so that means after 10 years he would have paid it all back. So the amount owing after 10 years will be nothing. So the amount owing up to 10 years will be nothing. So now I need to come up with an A10, and that's easy because if this was a 10, then that would be a 10, that would be a 9, and this would go down to 8, and then I'm going to end up with a geometric sequence in here. So okay, A10 is equal to 5 times 10 to the 6. Let me put this in line. 1.0, I'm copying the line above. 10 minus y outside of, I'm going right backwards. 1 plus 1.036, and this is just going to go up till I get to 1 minus y1, because that's a 2, and I just have a 3 here, so this will be 3, 6, 7, 9. Okay, so I know that this is equal to 0. Okay, I'm going to move this over here, which puts a y there, and then I'll have to divide by all of this. So that will go underneath here. So that means y equals 5 times 10 to the 6, 1.036, 10. And then all of that junk goes underneath. So 1 plus 1.036 plus blah 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 plus 1.036 to 9. Okay. Alright. Now this thing down here, that's a geometric sequence. A is 1, R is 1.036. So the sum of the first 10 terms is going to be A outside of R to the power of n minus 1. 1.036 minus 1. That's also on your reference sheet. That's equal to yeah, I don't really like that I'm going to be rounding here. Maybe I don't round. Maybe I go. Oh, this is going to look so disgusting. 5 times 10 to the 6, 1.036, 10, all over 1.036. You need to make sure you type this into the calculator correctly. On. Okay, that's around about equal to 604,241. Okay, that seems massive, but in the grand scheme of things, he's borrowing $5 million, so 604,000 isn't that much. Well, relatively speaking, I guess. So that seems about right. Is there a C? God damn it, there's a C. How many marks is that? 1. Be generous. Calculate, correct the nearest dollar, the amount owing after 5 years. Wow. Okay. So that's the amount owing after 5 years. So I'm going to have to write that line that's at the top, but with a 5 in it. 5. And I know what y is. 5 times 10 to the power of 6, 1.036 to the power of 5, minus, oh, that's that kind of mean. It's y, which is 604,241, and then it's going to be the sum of all these things, but if that was a 4. So times a outside of r to the power of n minus 1. So I'm just finding the sum of it. So that's s of 5. It's going to look like a 5. S of 5. Okay. So that's equal to. I just had a bunch of days today, Thursday. Why is my thing? YouTube is not receiving enough video to maintain smooth streaming. Excuse me? Denied? Please work. So that, oh, screw it, keep it. Okay, type all that to the calculator and I get 2,720,470. So that's 2,700,000. That's how much they owe. That kind of makes sense because it's halfway and that's kind of close to halfway. Obviously, it's not going to be exact because it's in compounding. Right, 30. Getting there. Oh, that page should be back one. Where's that page? You can go there. That was 28. I've done 29, 28, 29. So I'm up to this. Oops, shouldn't have done that. Oh, I'm up to the last page. That's nice. Okay. I've just done the exact same thing. Bear with me. Just give me control. Let me make a new page. Please let me make. God. Let me make a new page. Thank you. Okay, 30. Consider that function. Okay. Oh, I've got excellent condition again. Isn't that nice? Alright, consider that function. Show that the derivative. Okay, it's giving me the derivative. How kind. Looks like I'm going to use the product rule. So f dash x. It's going to be v u dash plus u v dash. V is the second thing. E to the negative 0.4x. U dash is going to be 8 plus, now u is that 8x plus, times v dash, so that's the negative 0.4 e to the x. No, 0.4x. Alright, let's tidy that up. What have I got in common? I've got this and an 8. So 8 e to negative 0.4x outside of, there was just one of that on the left, and x negative 0.4x on that side. That's all I got. What does it want me to show? That it's, oh, okay. 8 times that. So 8, oh my God. 8, what's 8 times 0.4? 3.2x. E to the minus 0.4. So all I did was times that by that, and then that by that, and that got me that. No. Cool. Done, as required. B. Too close. B. Hence find the coordinates of the stationary point and determine its nature. Oh, 3 marks. This is probably mental then. Okay, so I'm leaving the second derivative, well, the first derivative equal 0. So that means 8 plus 3.2x times e to that has to equal 0. It's a little bit hard with exponentials because with the null factor theorem you'd say either that's 0 or that's 0. Well, it's not possible for that to equal 0, so therefore that other thing has to equal 0. So 8 plus 3.2x has to equal 0. Or the reason that's not possible is because there's asymptotes and there's nothing I can point to there to make it 0, it'll just be 1. So that means 8 equals minus 3.2x. That means x equals 8 divided by it's 2.5. Okay, 2 positive 2.5. Should that be negative? By my mistake? Yes, because that whole thing was negative in the first place. You idiot. That's a minus. Minus means that's positive. take the 5 with you. Minus, minus, minus. That's F, minus. Okay. Easy mistake. Okay. Minus 2.5. Positive 2.5. Minus F. Okay. So that's my stationary point. What does it want? Hence find the coordinates of the stationary point. Okay, so when x is equal to that, y is equal to, so I need my original function, which was 8x e to the minus 0.4x. Okay, that's equal to, that thing there is 2 times 8, and then times by 4, that's 20. E to the 2.5 times 4, that's the same as 5 times 0.2, which is 0. Is that just 1? That's 1, e to the minus 1. So it's like 21e. Okay, so the stationary point at 2.5, 20 e to the minus. I left it exact. You could type that to calculate if you wanted, but who cares? Okay, that's my stationary point. Is that it? Oh, it's its nature. Okay, so that means I need a different. Oh, I have to differentiate that again. That's why it's 3 marks. Second derivative. Let's put it again. Okay, I'm looking at this thing up here. V times u dash. Now that's just minus 3.2 plus u v dash. Okay. Do I want to tidy that? At the end of the day, just going to substitute stuff into it. What am I saying? 2.5. What's it doing that? It's not doing that. Okay, so when I sub all that in, I'm not going to do that because I cannot be bothered. I just need to know whether it's positive or negative. Well, let's think about this. I'm going to have a negative times a positive, and then no, that's going to be too hard to work out. I just need to know whether it's positive or negative. It's negative, okay, so it's less than 0. That tells me it's a maximum, if it's a max, slash concave down. Okay, that's it. C. Excellent condition still. C. Over what interval is it increasing? Okay, so I need to know when so for it to be increasing, that means the gradient has to be positive. That would tell me it's increasing. Now the first derivative is, that was this thing here, let me copy this. So I'm wondering when that is bigger than 0. I need to expand that. Well, okay, can this thing ever be negative? No, this thing can't be negative. What's minus the pair of minus? Okay. Since this can't be negative, it's just that again. Okay, so that means negative 32x is greater than minus 8, which means x is, now I swap that, 8 divided by negative 32. 8 divided by 32 is a quarter. It's less when it's less than a quarter. Okay. Is that right? 8 divided by 32. concerned slightly because that's not the answers. How the hell? You need the A over and divide by. I wrote 32. 3.2. What am I doing? There's a point there. Okay, so that is the 2.5. That's interesting because my stationary point was at 2.5. So up until my stationary point, this thing's actually increasing. So it's going to help me when I go to draw it. Which I think the next one tells me sketch the graph. Yeah, okay. Now I know that. Let's just draw the bloody thing, eh? I know at x, so let's call this 2.5. I know that the y value is 20 e to the minus 1. 20. I just need to round about what that is. Okay, it's about 7. So let's call this 20 e to the minus 1. So at there's a maximum concave down turning point. Everything less than that, it's increasing. So in other words, it's just always like this. So let's just go like that. I don't know what my intercepts are, but where's my original function? The original function, think about this, if I put a 0 into that, it's going to be 0. So it's going to cut through the origin. So it definitely cuts at 0, 0. And then I just need to figure out what the rest of my graph looks like, I guess. I just think about what happens like as x gets really big. So if I shoved a massive x into this, just disregard the 8x for a second. If you just put a massive number in a power, you're making the thing a massive fraction. So you're kind of going like 1 on, it's kind of like 1 on e to the x because of that minus there. If I make this massive, that means my number is going to be massive. 1 on massive is tiny. So that means I'm going to kind of approach 0. So it's going to kind of go like this, approach 0. That makes any sense. And you can verify it by just shoving like right all you do is just put like 999 into the original equation, and I bet you it comes up to 0 or something really close to 0. Okay. 30. Oh, is that it? Oh no, E. Over what interval is the rate of change of f of x increasing? What interval is the rate of change of f of x increasing? So the rate of change. The rate of change increasing. So that means the second derivative, when is that positive? So looking for the rate of change of, so you're asking, because when the original function is increasing, that's asking about the derivative. So if you're asking when the derivative is increasing, you're asking about the second derivative. So E. So I want to know when this is greater than 0. I had the second derivative somewhere. Okay, it was this bloody thing. So I wonder when that's bigger than 0. Maybe I should have tidied this up before. Okay, what do I have in common? I've got an e to the negative 0.4 x in common. There's a minus 3.2 plus minus 0.4 times 8 minus 3. Okay, I want to know when that is bigger than 0. Okay, well, the same argument always. This thing is always bigger than 0, so I only care about this. Okay, let's expand this. Minus 3.2, what's 0.4 times 8? That's going to be negative 3.2 plus 0.4 times 0.2. 0.4 times 1.28 1.28x. I don't want to know when that's bigger than 0. So that's minus 6.4. Let's move the minus 6.4 over, so that's 6.4 there. 1.28x, that needs to be bigger than 0. So 6.4 divided by 1.28 is 5. So when x is bigger than 5. Okay. So that means about here, 5. That would be a point of inflection there. That's a point of inflection. Because if this part is increasing, okay, that means I would have drawn this slightly wrong. It means it kind of goes like that. That makes sense. So that, so from this, that's increasing. That part there is decreasing. And then I showed before that that's increasing. That's a cool question. Kind of gets you to draw it, but it shows you the steps of how you would do that. I don't know how that's 3 marks, but yeah. Okay, I believe we're up to the last question. 31, max min. Okay, maximum minimum question. Surely everyone's favorite. Well, I haven't got another 30 minutes on this one. 31A. Okay, let's just start with what I'm trying to show. I'm trying to show that A2y is equal to root 3 on 4 y squared. Wow, okay. A piece of wire is cut into 2 pieces. One is meant to form a square. Okay, let's draw a square. Eh? One is meant to form a square. That's not even a square. And the other, an equilateral triangle of side length y. Boom, 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 boom. That's y. Let A1x be the respective areas of the square. So this is A1x doing that. This is A2y. Respective areas of the square and equilateral triangle. Show that. Okay. I don't know the perpendicular height of this thing, so I'm trying to find this. And it's also not right angled, so I'm going to have to use A equals half AB sine C. That's not too bad because I know that A and B are the same. They're both y, so I'm going to write y squared. I actually know what every angle in here is. It's 60. So that's sine 60. That's a half y squared. Sine 60 is root 3 on 2. Okay, so that's where the root 3 on 4 comes from, y squared, and I'm done. That was easy. 1 mark. Okay. I don't know where I wrote A again. B. Show that the sum of the 2 areas is given by... Okay, well that's not too bad because I know what... It tells me that the side length of this is x. Okay, so A1x plus A2y. Well, the square is just x times x. And I already know what the triangle is because it made me work that out before. Okay, show that the sum of the 2 areas is given by... Now, see how that thing there only has x's in it and I have y's? That means I need to be able to write y in terms of x. So, what am I told about the 2 pieces of string? A piece of wire length 24 is to be cut into 2 pieces. Okay. Okay, so I know that that plus that plus that plus that plus that plus that plus that is 24. So I know that 4 x's plus 3 y's. So that plus that plus that plus that is this. That plus that plus that is this. I know that that's equal to 24. Now, just looking at what I'm aiming for in B, I'm aiming for something that only, like this x squared I have. This is what I'm trying to write in terms of only x's, but I've got it in terms of y's. So what I'm going to do is rearrange this thing. Minus 4x. 24 on 3 is 8. Minus 4 on 3x. I'm going to call that 1. I'll call this 2, and I'm going to put 1 in 2. So that's equal to x squared plus root 3 on 4, that squared. Do I have to go further than that? How much further do you want me to go? I've got to get a 4 root 3 and a... Okay, how the hell? I think I should have left it as a fraction if I'm going to get that. I'm just looking at that. See that 9 on the bottom? That's probably come from this squared. Okay, I'm going to rewrite this as 24 minus 4x on 3. So you've got to try and think about like what you have, what you're trying to get to. So I'm just going to do that over 3. So like forget this line exists pretty much. Now if I do that, I can factorize the top line. You factorize the top line, you get a 4 outside of 6 minus x. That's where that comes from. Over 3 squared. And then what I'm going to do is I'm going to square this and bring it out the front. So maybe I'll write a little bit bigger. X squared plus, okay, so root 3, that's what's already there. I'm going to have a 4 squared and a 3 squared coming out. So that and that is that and that squared. But I've still got my original 6 minus x squared in there. Okay, x squared. Now, one of the 4's cancels, that's 4 root 3. The bottom's going to have 9. That's going to be 6 minus x squared. And oh, that was a good one. What a good question. I actually really like minimum and maximum questions because you have something to aim for. Okay, I've got 8 minutes to do this. 3-mark question. Should take me 5 minutes. Hence show that s is the minimum value when x is equal to that. Okay. So whenever it says minimum value, you should just immediately think differentiate. It's told you that it's s, so you're differentiating s, derivative of s with respect to x. Now, what is s? Oh, the sum. Oh, okay, so this was s. Okay, so I'm just going to differentiate this. That's 2x. Okay, chain rule, so 2 times that is going to be 8 root 3 on 9. 6 minus x, 2 becomes a 1. And I go times by the derivative. The derivative is just minus 1, so minus there. I am looking for a stationary point, so I want that to be equal to 0. I'm going to have to expand this to get the x by itself. So 2x minus 8 root 3 on 9 times 6 plus 8 root 3 on 9x equals 0. Wow. This just times everything by 9, so then I get rid of all that. So 18x minus 8 root, no, what's 8 times 6? Oh my god, 56? Because 8 times 7 is... I seriously don't know what 8 times 6 is. 48. 48 root 3 plus 8 root 3x equals 0. Okay, x outside of 18 plus 8 root 3 equals 48 root 3, so move that over. One of my equal signs. Okay, that means x is, stop it please, x is equal to, oh, I just thought I differentiated that wrong for some reason. 48 root 3 on 18 plus 8 root 3. Okay, and that's equal to, off the top of my head, something, I'm not typing that in, cool. What am I trying to do? Show that it's a minimum when x equals, oh for God's sakes, I need it in that form. Oh, where's the 11 come from? Okay, well let's look at the form. It's being rationalized for starters. Okay, what's all this doing? Can I halve everything? What's half of 48? 24 root 3. 9 plus 4 root 3. Does that look anything like... Yes, I've got them. Oh, I've got a minus there. Oh, okay, they're rationalized by conjugate. So that's how they get the minus. Far out, I'm running out of room. Move here. Put the 9 with me. Move here, please. Okay, I'm going to rationalize the denominator by timesing by 9 minus 4 root 3 times by 9 minus 4 root 3. That's where that's going to come from. There's still 24 there, it's not, okay. Okay, 24 root 3. Again, you just got to think about what you're trying to get to. Minus. Okay, that's the top. That's the numerator. Denominator is, it's a difference of two squares. So it's the first thing minus the second thing. So 9 squared minus 4 root 3 squared. That's the whole point of rationalizing the denominator, is that that middle term cancels. That's the whole point of doing a minus and a plus. That top line, that's going to, I guess that 24, so I'm trying to look at what I'm trying to aim for. So like this, 8 root 3, I've got a 24 root 3, let's just leave the top line, because it looks pretty close. What's on the bottom? That's 81. 81 minus, okay, that's 16 times 3. Well, 16 times 3 is 48. What's 81 minus 48? Is 33. Okay, that's kind of nice because I'm feeling like that's where the 11 comes from. 24 33. 20. Okay, so 24 divided by 33 is 8 on 11. So that's where all that comes from. 8 on 11. The root 3 is in numerator. 8 root 3 on 11 outside. 9 minus 4 root 3. Wow, all three of them will show that questions. Yeah, right, but just keep in mind that a show that question means if I couldn't do the first part, I could do the second part because they gave me the answer. And I could do the third part because they gave me the answer to the last one. 58 minutes. And we're done. Wowzers.